Hello, this is Andrea Hendricks. The object of this video is to show you how to graph the inverse cosine function, again stating the domain and range of the function and evaluating that function. So just as we looked at the graph of sine to get the inverse sine function, we need to look at the graph of the cosine function to get its inverse. So I have drawn for you the graph of cosine over two full periods from negative 2 pi to 2 pi. And we see the same problem here, that this graph is not one-to-one, right? If we draw a horizontal line through the graph, it's going to cross more than the 1 point that we need for it to be one-to-one. And so we're going to have to do a similar thing that we did for the sine. We're going to have to restrict the domain of the cosine function on an interval for which we have all of the y values covered. That is, we need to have what? Well, we know first of all the domain of the cosine is from negative infinity to infinity, and the range is from negative 1 to 1. So we need to restrict it to a piece that is going to have the negative 1 to 1. So what can we do? Well, if you think about the way we restricted sine, it was one of those pieces as we came out of the top of a curve and we're going down to the bottom part. So it's really the part from the highest point to the lowest point. So if we can represent that, like here, from the highest point in one of the periods to the lowest point, that covers all of the range values, and it is also a part of the graph that is one-to-one. So let me show you how that works. So if we look at the restriction that I just drew on that last graph, we see that we have from 0 to pi. It's going to cover all of the range values that we need. So the graph of the restricted cosine function has this domain. So I'm going to again put a d sub r for the domain of the restricted cosine. Is from 0 to pi, and the range is from negative 1 to 1. Now that we know the restriction on the cosine, we can get the graph of the inverse cosine. And you may want to do this by hand so that you can get this more into your memory. But the idea is that we want to interchange the points that are on the graph of the restricted cosine to get the graph of the inverse cosine function. So if we have the point 0, 1, that's going to become the point 1, 0. Pi over 4 square root of 2 over 2 is going to become square root of 2 over 2 pi over 4. 0, or rather pi over 2, 0 is going to be 0 pi over 2. You could graph a lot of these points, but these are just some key points. Pi, negative 1 will become negative 1 pi. So we have here the graph of the inverse cosine, which is again denoted cosine inverse of x, or arc cosine of x. Okay, again, don't let that negative 1 make you think of reciprocals. That's not what it means. The negative 1 in this case really does mean the inverse function. Well, what is the domain of the inverse cosine? Domain is, well, it is the range of the cosine, right? It is from negative 1 to 1. And our range is the domain of the cosine, which is from 0 up to pi. So if you understand one of these inverse trig functions, the others are really going to follow suit. The only difference is where you have to do the restriction. But so think about this. The range being from 0 to pi means that our output of the inverse cosine is really going to be an angle that is in either quadrant 1 or quadrant 2. If the input is positive, our output is going to be an angle in quadrant 1. If our input is negative, it's going to be an angle in quadrant 2. So that might help you as well. So quadrant 1 angles are going to have a positive input, and quadrant 2 angles will have a negative input. Again, as long as they're in between the negative 1 to 1. So let's make this statement here that if we know that y is equal to cosine inverse of x, that is true if and only if cosine of y is equal to x. So again, we're asking ourselves, what angle has a cosine of x? And more importantly, what angle in the interval from 0 to pi has a cosine of x? So let's evaluate these particular problems. If we want to find cosine inverse of 0, we're trying to think about this. What angle has a cosine of 0? So you can either use your unit circle. On your unit circle, think about what angle has a cosine of 0 and answer, or we can look at the graph of the inverse cosine. I personally don't even really think about the graph of the inverse cosine. I always think in terms of the unit circle. The angle that has a cosine of 0 is what? Right, it is pi over 2. What about cosine inverse of negative 1? So here we're thinking about what angle has a cosine of negative 1. If you think about the unit circle, that is going to be at pi. So make sure our answer is between 0 and pi. What about the arc cosine? So again, another way to say the inverse cosine of negative square root of 3 over 2. So we're thinking about what angle has a cosine value of negative square root of 3 over 2. Well, and that is going to be, if you look at your unit circle or know this from memory, it's going to be 5 pi over 6. What about arc cosine of square root of 2 over 2? The angle that has a cosine of square root of 2 over 2 is pi over 4. Cosine inverse of negative 1/2. So we're thinking about the angle that has a cosine of negative 1/2. It's got to be an angle that's in the second quadrant because it's negative, and that is 2 pi over 3. And lastly, what about cosine inverse of negative 2 pi? Right, is negative 2 pi in our domain of the inverse cosine? It is not, because our domain has to be between negative 1 and 1. Negative 2 pi is negative 6.28 or something like that, which is not in the domain. So this one is undefined. Okay. Now let me show you the graphs on the calculator. So if I wanted to enter the inverse cosine function, I'd have to do second cosine x. And for my window setting, I did from negative 2 to 2 for my x, and my y values I did from 0 to pi, and then my y scale I did as pi over 4. Okay, so think about this. So we have our point negative 1 pi, and 1, 0. So we have what? An input or domain from negative 1 to 1. Our range is from 0 to pi. So we know exactly what that should be. Now here's an example where I entered cosine inverse of negative 1/2. So there the output value is going to be the angle whose cosine is negative 1/2. And you can verify in your calculator that that is in fact the value of 2 pi over 3. Okay. And if I did cosine inverse of negative pi, well, negative pi is not in my domain. It is negative 3.14, so I'm going to get an error message there. So that concludes how to graph the inverse cosine and to evaluate that function. If you have any questions, please contact me.